Hello. So we are now looking at part A of 18. So the question is, evaluate the limit, right? So if I'm looking at this, you typically want to just plug in 0 when you see it, or plug in what your limit goes to just to see if it works. Probably won't, but we will just to see. So we get sine of 0, which is 0, right? Times 0, divided by 0 times secant of 0, which is 1. So we have 0 over 0 that is indeterminate. I don't know who wins, right? If the bottom wins, I go to infinity. If my top wins, I go to 0. So I really don't know. It can be anywhere between the two. So, how do I evaluate this? Well, I remember the this little tool I have in my pocket that if I have sine of something, right, theta is just a placeholder, divided by that something, and that something is going to 0. Okay, this is important. If it goes to anything else, this does not apply. So if my theta goes to 0, and I have sine theta over theta, then this equals 1. Okay, cool. I almost have that between the sine and the x. If that was a 6x, I would. Okay? So what I'm going to do is manipulate it to where I have a 6x in the bottom. Okay? So this is what I want. I want that. I get it if I have this. So comparing this and this, they're the exact same thing. All I did was multiply by 6 over 6, right? By 1. So I haven't changed my limit. But by doing this, all of a sudden this goes to 1. It's really cool. I like that a lot because now let's see what happens if x goes to 0. Well, secant of 0 is 1. Just like, because, secant, right, is equal to 1 over cosine. And cosine of 0 is 1. Right, so that goes to 1. So 1 over 1 is equal to 1. Right, last I checked, 1 over 1 is 1. So this is equal to 6 over 1. So my answer is 6. Let's move on to part B. So I'm in a pretty similar situation. I want to get this identity. It would be great. So I could kill that sign over there and life would be awesome. But to do it, I would need an 8x on the bottom, and I need 2 of them, right? Because it's a square. So let's make that happen. So sine 8x divided by 8x, and then squared, because I've sine squared. If I didn't have sine squared, I wouldn't have this squared. So what I need is 8x squared in my next numerator. So looking at this, I haven't changed my equation. That's the most important thing. It's the exact same thing, I just manipulate it a little bit algebraically. But now this whole thing goes to 1. Okay? And you might say, great, maybe this works out just like this one did. But if I plug in 0, I get 0 squared, 0 over tan of 0, which is 0. So I'm still stuck, right? Still have 0 over 0, still indeterminate. But we know another one of these little tools that limit as x goes to 0 of tan x over x also goes to 1. Okay? And this should make some sense because tangent is sine over cosine, and the cosine goes to 1, and the sine is still there. So it's actually almost the exact same thing as this limit. Just changed a little bit. But I can use that here. Okay, so this is equal to 64x squared over tan squared x. So here is my limit that I know. Okay. Now you might say, well, look, this is tan x over x. That is x over tan x. Should be different, right? Well, you're right. It's the reciprocal. Okay. So this is equal to 1 over 1, but it's still 1. So this still holds true. It still goes to 1. Well, really 1 squared, right? But still 1. So my answer is going to be 64. Okay, so we are now looking at 18 part C and part D, which are pretty similar, right? The only difference is what the limit actually goes to. So let's look at part C. So first things first, right, we try and plug it in. Try and plug whatever my limit goes to in my work. So in this case, we plug in pi, right? We get sine of pi over pi plus tangent pi. Okay, so if we draw a unit circle, and we say sine of pi is right here. Okay, the y value is 0, so sine of pi is 0. Tangent of pi, right? Tangent is sine over cosine. So sine is 0, right? And cosine is -1. So still goes to 0, right? So I'm going to rewrite this. Now I have 0 over pi plus 0. And this is obviously just 0. So your answer is 0. No simplification needed. All we had to do was plug it in. Now for part D, it won't be as simple. Okay? So if I plug in 0, I get 0 over 0 plus 0. So 0 over 0 is not okay, right? That's indeterminate. 0 over pi is determinate. Important distinction. So with this one, we have to manipulate it some. Okay, so remember that the identity that we all know and love, where if we have sine of something that goes to 0 over that something that's also going to 0, is equal to 1. And same thing for tangent, right? Tan acts the same way as sine in this case. So if we can get these, we're probably going to get it right, okay? Because this is an easy simplification that would be great if we had it. Here it's not so simple to see, okay? You might be tempted to say, okay, I'll take this guy and break it up that way, but that doesn't actually work. You can't split up a denominator like that. If it was reversed, you could. You could say theta and sine and tangent and sine, or yeah, you could do it that if it was flipped, but it's not. So what we're going to have to do is be a little bit more creative. What we'll do is we'll multiply top and bottom, right, by 1 over theta. Okay, and it might become more apparent on why you do that, because if you look at the top, we now have sine theta over theta in the numerator, and we would have theta over theta plus tangent theta over theta in the denominator. Okay, so all I did was multiply through, right, and distribute that. So this is 1 theta over theta. No matter what theta is, it's going to be 1. Tan theta over theta is also 1, based right here. Sine theta over theta is also 1. So we're left with 1 over 1 plus 1, which is equal to 1/2. Now you might say, where does the actual limit come in, right? So remember, if theta is going to 0, That's the only time we can use these. So if theta was going to something else, it wouldn't be 1/2. But the fact that it's going to 0, it is. So 1/2 is our answer. All right, so we are now looking at 18 part E and 18 part F. So let's look at 18 part E. Limit as x goes to 1 of that junk, right? So when it looks like this, I don't have much to go on. I can try plugging in 1 and I'll get sine of 0, right? Because 1 minus 1 is 0, over 1 plus 1, which is 2, minus 2, which is 0, 0 over 0. I'm indeterminate. So I'm going to have to manipulate it, cancel, do something. So what comes to my mind is, why don't we factor that guy? So we have sine of x minus 1 over that factored out gives you x minus 1, x plus 2. Okay? So then we say, oh, whoa, look at this. Our favorite identity, right? Now you might say, look, the limit isn't going to 0. It's going to 1. So doesn't that invalidate? But if you look closely, you'll notice the inside of this sign is going to 0. That is also going to 0. They're the same thing. So essentially, these are just placeholders, right? It's important to remember. These go to 0, your identity holds true. So these are going to 0, so this does go to 1. So goes to 1. And we're left with 1 over x plus 2. If I plug in 1 now, I get 1 over 1 plus 2, which is equal to a third. And that would be my answer. All right, so let's look at part F. Now, part F, that's a cosine. There is a certain identity for cosine, which you should know. It's in your book. I don't know it off the top of my head, but important for you to know. Okay, so with this, I don't think I can manage to get something like this to happen. So what I'll use instead is squeeze, right? I know cosine of anything, right? Maybe I should just write cosine of anything will be between -1 and 1, always, right? So cosine of x plus 1 will also be between -1 and 1. All right, so now, if I want to get this in here, I need to divide everything by that. Okay, so -1 over x squared minus 2x minus 3 less or equal to my function less or equal to 1 over. Now on your test, it is important to write out every single step, okay? Do that. Okay, so now let's do the limit. So as x goes to infinity, right, really big number, this, right, this bottom denominator, that goes to infinity, okay? You might say, well, look, this is minus, a big number, so maybe not infinity. No, x squared grows way faster than x, okay? That's why he essentially wins. So I have -1 over a gigantic number, whole thing goes to 0, right? 1 divided by a really big number is really small. 0. Over here, exact same thing, right? So this also goes to 0. So that means my function itself goes to 0. Okay, so it's squeezed between 0 and 0. So the answer would be limit as x goes to infinity of my function equals 0.
The Teaching Center, UF's Learning Resource Center.